saying? Okay, look at the board. Everybody look. Let f of x be a pizza and let g of x be a pineapple. That means that f of g of x is a pizza with pineapples, right? And g of f of x is a pineapple with pizzas. What are we doing today?
Functions.
Functions? What's it called when we stick one function inside of a different one? And it's a composition of functions. Compositions of functions. So yeah, that's what we're doing today. Was that of me? No, it was of you. Oh, it was your cup. Okay. Fair. Yeah, I did. Are y'all ready for this? Composition of functions. So this is going to be a pretty quick lesson. I believe that you've seen all of this before. These get pretty neat. I don't mind this lesson. I really like it. So that being said, we don't know that it's the same for you, but it's fine. So this is going to be topic 2.7, composition of functions. And so we're just going to start really quickly at the top. It says, consider the following. Let f of x be 2x minus 3. That's a function. It's in function notation. F of x, meaning y as a function of x. That's where we get the f of x business, right? What's the benefit of writing an equation in function notation? Why is this better than to say y equals 2x plus minus 3? Don't they mean the same thing? You can't substitute. I mean, you could, but you can't tell what you're substituting for x. The benefit of function notation is that I can see what I'm substituting, okay? What I'm inputting for x. So in the first, we've got evaluate the following. It says f of 5 equals. So what we want to do is we want to take this function, and everywhere x equals 5, everywhere we see x, we want to substitute out x and substitute in 5. Everybody good with that? Okay, so when we do that, what do we get?
7.
F of 5 is 7. Okay, what's f of c?
2c minus 8.
Good. What's f of 4a? Okay, so we're going to open parentheses on the x, and we're going to put in a 4a, which means we end up with 8a minus 3. I would agree.
That's too much math.
Oh, just wait. The next one, we're inputting a whole function. We're inputting 5x minus 1. So I'm going to start with f, which says 2. When I hit x, I'm going to open parentheses and drop that 5x minus 1 into parentheses in place of x. Finish minus 3. We could play hippity-hoppity distributive property here. We've got 10x minus 2. Be careful that it's not 10x minus 1.
Oh, no.
Oh, no. I figured I'd catch somebody there. So 10x minus 5 would be our answer. Always trying to think ahead, Truett. Always trying to think ahead. 10x minus 5. Make sure that you distributed the 2.
Yeah, it's not going to get more complicated than that, right?
Oh, nah, surely not. These are just like some warm-ups. This is not even example 1. All right, so it says sometimes in math, we will plug a value for x into a function and then use that output or that answer to plug into another function. When we plug an output of one function into a different function, this is called a composite function. Confused yet? Okay. So it says let g of x equal 3x plus 1. Let g of x equal 3x plus 1. Let g of 2 be c.
What?
Find g of c. Okay, so hold on. Yes.
It equals g of 2.
Okay. Pause. Everybody pause. There's a whole lot of chatter back there, and I need you to settle. Y'all are confusing as all get out. G of x equals 3x plus 1. G of 2 is c. So what we've got to do first is find g of 2, which is 3 by 2 plus 1. So 7. We understand that? G of 2 equals 7. Well, they told me right here, g of 2 is c. So if g of 2 equals 7 and g of 2 equals c, what do we know about c? C is 7. Now find g of 7. Because g of c is the same thing as g of 7, which means we're going to have 3 by 7 plus 1, 22. Okay. Slow it down. Everybody understand? Let's not just start rattling off a whole bunch of hullabaloo. All right, so composition of functions. It says there are two ways. There are two ways we can write composite functions. Two different ways. One way I absolutely loathe. It's to say this. Fog. F-O-G. It's a little bitty O. It's in the middle between the two letters. It's a tiny little O. I hate that with a passion. Every time I see that, I rewrite it. Every time. Okay? But you're going to see it, so you got to recognize it and you got to know what it means. The other way that we write a composition of functions is we might say f of, and instead of x, I might put another function in here. F of g of x. Okay? F of g of x. These two things say exactly the same thing.
Where's the x for the first one?
Right. I don't like it. What it means is both of these, we read these expressions. So we read these expressions. When we see these letters, we say f of g of x. Both of them say the same thing. F of g of x. You don't see the x on the first, but it means the same thing. It means f as a function of g.
It would be fog of
Insane amount of functions.
So just fog.
And you just start nesting them, like those little Russian dolls that pop out on Toy Story. Right. All right, so here we go. Are you ready to move on? Important note, it says when working with composition functions or when working with composite functions, we start on the inside. We start on the inside. I don't know what it means by right. I think like the one, I guess. Yeah. So if given f of g of x, evaluate g of x first. Evaluate g of x first. Use the answer from g of x and then plug it into f of x.
What if f of x is the one inside?
Well, then you're going to go backwards. You're going to evaluate the inside one first, whichever one happens to be on the inside. Okay? Huh?
Are you going to teach your algebra to kids?
Yeah, I was like, I thought we
My Algebra 2 kids are killing it right now. They're doing a fantastic job. Yeah, they're working harder than any other class I teach right now.
Are we killing it? Yes, our mental.
Y'all are kind of attacking it with like a soft mallet.
Dude,
Are those
Malik.
inflatable ones from the carnival?
Like maybe one an inflatable mallet. Like it's definitely not a meat cleaver. We're getting better. We're getting better. No, that Algebra 2 boat, I'm really proud of them right now. Doing a great job. All right, so here we go. We've got two different functions. We've got f of x equals 3x minus 5 and g of x equals 2x plus 1. Evaluate the following expressions. So first it wants f of g of 3. So one option is to take this f of x sentence and inside it, so I'm going to kind of work up here in this blank space. I'm going to start writing f of x. And when I hit x, I'm going to replace that with g of x, which happens to be 2x plus 1. But now instead of x, I'm going to replace that x with a 3, right? So this is one option, and we could solve. I think that's kind of really complicated.
Yeah.
I would prefer that we work from the inside out and we say, okay, let's find g of 3 first. It would be the same. G of 3 is going to be 2 times 3 plus 1, which is 7. So now we'll replace g of 3 inside of this x equation with 7. And we're looking for f of 7, which is going to be 3 by 7 minus 5. 21 minus 5 is 16. Would we have gotten 16 up here? Yeah, that's 6 and 7 would be 21 minus 5, 16. Yeah, it's the same. But I think it's a lot easier if we evaluate the inner function and then plug into the outer function. Okay. All right, so let's do f of 3. This answers Ruth's question. What if it's switched? Well, f of 3 is going to be 3 times 3 minus 5. I want you to notice that every time I'm changing out x, I'm putting into parentheses. That's huge. Make sure you're doing that, even when it's just a little bitty number. Bless you. So we got 3 by 3 minus 5 is going to be 4. So now I'm looking for g of 4. So 2 by 4 plus 1 makes 9.
There's 2 F's on this one. This is pizza.
Oh, good. Good, good. This is pineapple pizza. All right, so letter C, f of 4. Same process. Start with your inner function. Evaluate f of 4. F of 4 in this case is going to be 3 by 4 minus 5, which is 7. Okay. Yes. So now we're looking for f of 7, which means I'm using the same function again. This time I'm plugging in a 7 for x. 3 by 7, 21 minus 5, 16. Well, I suppose we could say f of 4 is equal to f of g of 3. Who knew? What does that mean? G of 3 and f of 4 are equal. Yeah. Okay. Yes, everybody, yes. All right, so example 3, it says, using the equations for f and g from example 2, find expressions for the following. So this time we're not actually plugging in. We're doing the thing where we write one of the equations in place of x in the other equation. Okay, so f of g of x. That means I'm going to start writing f.
So it'd be 3 and then
Right, so I'm going to start writing my f function. I'm going to use blue for f. And I'm going to use, Ruth, what color?
pink.
Pink. That was sweet. For G. Okay, so inside my F equation, I'm going to start writing 3 open parentheses. And in place of x, we're going to drop in the whole g of x in it. It's 2x plus 1. And then we're going to close parentheses, and we're going to keep writing the rest of f. And then they want you to simplify.
Oh my gosh, why is there so much freaking, what's it called? When you have like the 2 functions, you're multiplying them. There's 2 of them.
Distribution. Oh. So 6x plus 3 minus 5. Final answer here is 6x minus 2. That would be our expression for f of g of x. Okay, so I start writing the outer function. When I hit x, I pause and open parentheses, insert the inner function, close parentheses, and then finish. Okay. On the second one, I used pink for g, so here we go. 2, open parentheses, and in place of x, I'm going to put f of x, which is 3x minus 5. And then we're going to close parentheses and finish writing my g sentence, which has a plus 1 on the end. So I've got 6x minus 10 plus 1. G of f of x must equal 6x minus 9. Have y'all already turned it over? Okay, fair enough. Moving on. Example 4.
C makes me mad.
C makes you mad. Do y'all want to just have some time to do these right now? Okay, I will do them on my own. You do them on your own.
You do C first.
Life is good. Can I do C first? C first?
Yes.
Okay. Truett hates C, so we'll do C first. C says cop X. I hate it. I'm going to rewrite as k of p of x. Remember, those are the same thing, right?
So that mean B, it was,
H of m of negative 1. So if I'm writing k of p of x, I'm going to start with k. The equation for k is x squared plus 4x plus 5. And every time I hit x, I'm going to open parentheses and put in.
So do we start with an open parenthesis?
Yeah. And I'm going to use a new color, I think, for p. Square root 3x plus 1. Close parentheses squared. Plus 4, open parentheses, gross, square root 3x plus 1, close parentheses, plus 5. So, yeah, so when we simplify, right? So first, just write it. Notice that I wrote the maroon for k, and I put blue for p. So I wrote the k function, and in the place of x, I put p. Are y'all with me on that?
Yeah.
Now we can simplify. So the square root of 3x plus 1 squared makes 3x plus 1. 4 times the square root of 3x plus 1 can be simplified to 4 times the square root of 3x plus 1. Can't distribute the 4, can't get into the radical sign. At the end, we have plus 5. So the only thing else I can think of to do here is combine the 1 and the 5. So 3x plus, say it louder.
3x plus 4.
Plus, I got plus 6 plus 4 square roots of 3x plus 1.
I don't put that.
It just seems like a lost
I just pushed the 6 on the end.
Okay?
Shouldn't the 6 be at the very end?
Sure.
Does that matter?
I mean, what's standard form? Yeah?
Yeah. Yes, it does matter.
Constant caboose. I like it. You try A and B. And on B, don't get mad at it, just rewrite it.
What's this?
This
This whole deal right here. The whole chart.
wait, so instead of, because I figured out B, I got 6x squared minus 5x minus 6.
Why do we have to use Y?
What?
Then I just flipped out the sign.
This whole chart right here.
We haven't gotten there yet.
Negative 1 squared is positive.
We're on A and B. Truett, are you talking to me?
Yeah, I was.
I'm sorry.
Well, so, I think it was mostly right.
Okay?
Would it just be, it'd be 6x, or no, it'd just be 6 squared, which would be 36, wouldn't it?
I don't know. I'm working it right now.
Hold on.
Poor
Pause.
Carson. Carson's going to be watching this and be like, what was
It'd
happening?
be 6. You're right. Thank you.
And Emma. Carson and Emma, they're home today. And Avery. All 3 of them. They're going to be watching this and like, they have
It's
lost their
warm.
ever-loving minds.
No, it's not, it's 5. You're so Why is it negative 5?
Because I subtracted. Negative 2 minus 3.
What about h times I got 5.
Yeah.
I got 5, not negative.
What do you do?
Did you make sure you're
Well, I put
by negative 1?
I put H and M next to
Yeah,
each other
okay, yeah.
and then distribute it to get one big function and then plug it for negative.
This is why you're so good.
Plug in the negatives on there. Right, you get negative 3.
Right.
You plug that into H. 2 times negative 2 minus 3.
I got 5, not negative 5.
graph.
Okay, I'm going to pause really quickly while y'all get this one. All right, moving on. So we've got a bunch of information here, okay? I don't want you talking while I'm trying to explain because I think that gets very confusing and very overwhelming, all right? So the first thing that I want you to see is the graph. The graph is going to be used every time we need f of x. Every time we need f of x, we're going to the picture, okay? Every time we need the function g of x, we're using the table, okay? I'm, for some reason, not able to use that. Every time we need g of x, we're going to the table. Every time we need h of x, we'll be going to this little piecewise function here. Okay, it's got lots of interesting information. Every time we need k of x, and here's where we have to do a little bit of work. We're going to be coming to this situation. It says k of x is a quadratic function with a horizontal translation of 2. Horizontal translation of 2 and a vertical translation of -3. So can we write the equation for k of x? It's quadratic. It has a horizontal translation of 2.
Inside parentheses, x squared minus 2.
X minus 2 inside parentheses. And then we've got to put it to the what power? To the second power. That way we square it, make it quadratic. And then minus 3 on the outside. Inside we had x minus 2 because we know that insiders lie. So to handle that horizontal translation, we made it lie. And then the vertical translation was -3 and we kept it. Looky there, we've got a function for k. Everybody okay?
You want to explain this piecewise one?
Yeah, we'll get there. We'll get there. All right, so example 5, we've got all these different functions. It says use the information to evaluate the following, if possible. Sometimes we just can't do it. So f of g of 3. F of g of 3. I'm just going to use black because I'm over all the colors. F of g of 3. So that means I've got to go find g of 3 first. G of 3 first. So I'm looking up here in my table. What's g of 3? No, g inverse of 3 is 2. Is there g of 3 in the table? So that's not defined. So f of g of 3 doesn't exist. G of 3 doesn't exist. That's why it said if possible. You go and define points. All right. The next we've got half 8. I hate that. How would we rewrite it? H of f of. So where am I going first? Find f of 8. So we go to this picture. F of 8. So that means I'm going across to 8 and down to find my output. Input 8, output -1. So now we're looking for h of -1. You want to explain how to do the piecewise function? Okay, so look. My domain x is -1. That means x must be less than 1. So I'm going to use the top function to evaluate. Okay, so the domain tells me which option of the 3 I get to use. It's like a menu. They tell me x is -1, so I go to the top option here. I'm going to find the absolute value of -7 plus 3 times -1. So h of -1 is going to be absolute value of -7 minus 3, -10. Absolute value of -10 would be 10. There's your answer. Whew. Okay.
K is 0.
Gawk 0. G of k of 0. Means in my k function, I'm going to first evaluate k of 0. So we're going to have 0 minus 2 squared minus 3. Everybody say -2 squared is not -4. Everybody say it.
-2 squared is not -4.
Thank you. What is -2 squared? 4. Okay? We don't always get our calculators, young humans. You've got to know some maths. 4 minus 3 is
1.
1.
Whoa.
K of 0 is 1. K of 0 is 1. So now we're looking for G of 1.
Does not exist.
G of 1 is not defined. So we put not defined.
F of 1 is 4. That's so cool.
Another point for Macy. Not defined. Right?
So we did all
Negative 4.
All of that work to see that it's not on the table because there's no X value 1 for G.
That is so stupid.
Okay?
Why would it-
All right, let's go on. Let's go on. Attention, young grasshoppers. F of 2. So the first thing I would do is go find F of 2, meaning when X is 2, what is Y?
There's 2 points.
At 2? There are 2 points at 2. Okay, so let me zoom in here on this situation. F of 2, there are 2 outputs. However, one of them is a whole. It's not defined. You must use the option that actually is defined. So F of 2 is 1. If only this option existed, F of 2 equals 4, and there's a hole there, you would say F of 2 is undefined. There's nothing there. Okay? So F of 2 is going to be 1. F of 2 is 1. So now I'm actually finding what is F of 1, which is 4. Let's go back to 100% here. F of 1 is 4. Questions on that one?
Wrong.
Anybody? Questions on that one?
F is stupid.
Okay, are y'all already on E?
yes.
I hate that.
Okay. G of H of 1. So I'm going to start with H of 1. H of 1 is what? H of 1
What? Negative 4.
is negative 4. Everybody understand on the piecewise? H of 1 is negative 4? Okay. So G of negative 4 is it defined? What is it? Pi. Pi. G of negative 4 is pi. That's our answer for number E. What even is this? It's a sandwich of badness.
There's not a 13 on the graph, though.
Okay, well, pause. Everybody freeze. Everybody freeze. Breathe. All right, so we're starting out with G of F of H of K of 3. 1 close parentheses, 2 close parentheses, 3, 4. Okay, so we're starting on the very, very inside. K of 3 is, that's going to be 3 minus 2 squared minus 3. So 1 minus 3 would be negative 2. I told y'all, these are like those little dolls that output each other. Right? Yeah, Russian nesting dolls. That's exactly what we're dealing with. So now we're looking for H of negative 2. That's going to mean that I'm using the top function. So we've got the absolute value of negative 7 plus 3 times negative 2. Everybody know why I picked the top function? Because my input value was less than 1. Negative 7 minus 6. Negative 13. So I'm looking for the absolute value of negative 13 would be positive 13. Okay. So now F of 13 is, my graph stops at 10. So F of 13 is not defined.
Did she just hear us?
Thus, G of F of 13 is not defined. End of story. We're done.
It was that easy.
Mm-hmm.
I know, I also did that too. That was so.
All right, so you guys have a worksheet that goes with this paper. I want to be able to check it mañana. Okay, tomorrow. We should be able to check it tomorrow. This is a pretty quick assignment. Won't be too bad.